Good afternoon and or morning. My name is Nicholas Bramhall, and I am going over my lab report for Lab 2. Lab 1, Physics 2. Sorry. Alright. So, what is this lab? This lab was a charge tape lab, and the point of this lab was to identify the charge that is on the pieces of tape. Now, how this was done was through observing when the repelling forces of the two sides of the electrons overcame the force of gravity, as the force of gravity was known. And so using that quality, we can figure out what the charges is. Now, we noticed that at the distance of 0.0127 meters, the forces were equal, and the hanging tape started to come up. And using this knowledge, you're able to calculate the total charge as 4.2 e times 4.2 e negative 9c. And in this experiment, the system was the top tape, and the surroundings is the bottom tape and everything else. Now, these are the formulas used. We have the force of electricity, of course, the electric field. We have the force of gravity, which is the simple mg, delightful. And then we have them equal to each other. We can see that expanded out over here, where we then solve for q. And yeah. Alright, so this is the experiment in a little graph form, as I'm sure you all are familiar. We have the blue tape here on the bottom that is coming up, and we're stopping when the red tape starts to come up. As we know, at that point, the forces are equal, and it's starting to overcome the force of gravity. Now, in the code simulation, with something similar happened in this. It's a still image, but in the actual code itself, at this point, the two were still and stopped, showing that they were at equilibrium and they were equal to each other, confirming our charge. We can see here on the left, we have the initial conditions of the constants, as well as the tape mass and the guess of the charge. And then we also have the objects down here, as well as the position of the distance between the two. On the right, we have the calculations in which we calculate the force of the electricity due to its current position and charge. And then we also have the force of gravity, and we calculate the F net, and then of course we update the position of the tape in regards to that. And then, as we saw in the previous slide, they were both still signifying that they had reached equilibrium and that the charge was the correct charge in this situation. Now, moving on from this, what if the electrons had a positive charge and protons had a negative charge, and what would the changes be to the observations made? And quite simply, there would be no change. In this case, the two positively charged objects would still repel each other, and a positively charged and a negatively charged object would still be attracted to each other. The only difference is now that the reason why they're being repelled is because it's positive charges instead of negative charges. Of all actual observations, there would be no change. Now, why is it important that we handle the charged tape as low as possible? Because what happens when you come in contact with the tape is the electrons actually leap off of the tape and come onto your hands, as your hands work as a bit of a conductor. And so it's actually taken away from the charge of the tape, which would cause it to where you need to be closer. The two tapes need to be close in order to overcome the force of gravity, skewing the actual results of the lab, giving a false answer for how much charge is on the tape, or initially, how much charge is on the tape initially. So that would contribute to possible error. There'd be human error in identifying the distance of all from the video, handling the tape, and also in creating code that doesn't accurately represent what happens. But we saw previously that due to the fact that the charge caused equilibrium, we can have assurance that the code was accurate. Alright, that's all I have for you today. Thank you so much for your time, and I hope you have a blessed day. Thank you.